video, we're going to be reviewing the Geometry Essentials vocab. So our first term that we're going to be looking at is the term for points. A point is just a location, and it has no shape or size. So what it looks like is just a dot with a letter name. So we call that point A, and you want to make sure that you name your points with capital letters. Our next word is a line, and a line is made up of points. It has no thickness or width. There is only one line through any 2 points. So what I mean by that is if I have point A and point B, I can draw only one line through those 2 points. This line is now, it has a line that we're drawing through it, but then we also mark the ends with arrows to show that this line goes on forever. We can call this line AB. We can draw it using the notation AB with this line shaped symbol above it. You could also call it line BA, or you could do BA with the line symbol above it. Or your last option is to name it a lowercase script letter. So I could also call this line M, and that's how we would say it, with that lowercase script letter. So you have lots of options, and it doesn't matter which order you're putting those letters in. For a plane is a flat surface that is made up of points. It extends indefinitely in all directions. They're created by 3 non-collinear points. We haven't defined collinear, but we will later in this video. What I mean by a plane, sorry about the calendar. What I mean by a plane is we have point A, point B, and point C. So these points, I could draw a line between A and C. I could draw a line between A and B, or a line between B and C. But these points are not going to form one straight line through all 3 of them because I can't connect them without making a curve or a bend in my line. But what I can make out of these 3 non-collinear points is what we call a plane. So this is now a surface, kind of like a piece of paper, that I now have my 3 points on. So I can call this plane ABC. It could be called plane BCA. It could be called plane CBA, or any other combination of those letters. So I could also have plane CAB. I could have BAC, or I could have ACB. So plane and then the 3 letters. Doesn't matter which order they're in. You could also just call it a letter, just like we named the line a lowercase letter. We can also label our planes as lowercase letters. So I could also call this plane P. So I have 2 choices there. My next definition is for a line segment, and that is just part of a line that consists of 2 points, and we specifically call those endpoints. So a line segment starts with 2 points, A and B, just like our line did above, but rather than connecting them and going on forever on either side with those arrow notation, we are only seeing that this line segment exists between point A and B, and that's it. So it ends at point A and it ends at point B. So we can just label this as either, we can call it segment AB, we could call it segment BA, or the shorter hand notation for that would be AB with just a line over it, or BA with just a line over it. And so notice the difference between the segment notation and the line notation. The line has the arrows on both sides, whereas the segment only has, or just has that line. It has no arrows because it doesn't go on forever. The last one that we're going to define like this is a ray, and that is part of a line that consists of an endpoint and all points on the line that extend in one direction. So what that's going to look like is I could have point A and I could have point B. And maybe this is a ray that starts at point A and continues on in one direction towards point B. So A would be the end point and B is what it's extending towards. So the way we could name that is to say ray AB, or I can label it as AB with the endpoint symbol. Now the order does matter here because A is my starting point and B is where it continues to. So when I write it as my arrow like that, I want to show that it's going from A and going to B. The next set of definitions kind of hits on multiple parts of what we just reviewed. So collinear, if you think about the word or the prefix co there, think of like a coworker. It's someone that you work with, or a colleague, or somebody that is co-hosting a party or something. So it's together. So when we think of collinear, the other part of that word is linear. So think about a line. So points that lie on the same line are called collinear. So when I see PQR here, you can see that we can draw a line straight through that. So these 3 points are collinear. However, when I have point X, Y, and Z, I can draw a line through X and Y, I could draw a line through Y and Z, I could draw a line through X and Z, but I cannot draw just one straight line through those 3 points. So these 3 points, X, Y, and Z, would be called non-collinear. The next vocab word that we have is coplanar. So again, think of coworker, or just like we heard collinear, they're going to be points that lie on the same plane. So very similarly, notice here we've got plane A and we have plane B. You can see that Q, R, and P would be coplanar. So we could say points Q, R, P are coplanar because they are all on plane A. So notice they're all on that plane A. However, point S here is on plane B. So we could say that points Q, R, P, S are non-coplanar because they do not lie all on the same line there. We just have point S that is kind of left out. It's on a different plane, plane B there, so they are non-coplanar there. And then an endpoint indicates where a segment or a ray ends. And we kind of saw that above, so we could have segment AB. And remember, this is just part of a line, and both of those A and B are endpoints. We could also have ray AB, where we have an endpoint at point A, and then B is just continuing on. So A there would be your endpoint. The last 2 vocab words we have are below. We have opposite rays, which are 2 rays contained on the same plane, the same line, that share the same point and go in opposite directions. So notice on this line, I have line JL is what I could call this. And within line JL, I have a ray called ray KJ, which is the red ray. I also have a ray called KL. Right now, because they are contained on the same line and they're going in complete opposite directions, these would be called opposite rays. Now, if I had a ray where it was J, and then KL like this, they are going in different directions, but it is not the complete opposite, and they're not on that 180-degree line anymore. So those would not be called opposite rays. They're just 2 separate rays. And then finally, we have the word intersection. So think about like an intersection when you're driving on the road. 2 streets are merging together. They're crossing at a point. And so it is the set of points that 2 or more planes or lines have in common. And so you can see my 2 examples drawn here. In the first example, we have line L1 and L2, and they're intersecting at point O. And so 2 lines will always just intersect at one point. In the next example, I have plane P and plane Q, so the red plane and the blue plane. Those are intersecting, and you can see that they meet right here. And that whole space, all of the points that are existing in that intersection, all lie on line M. So when 2 planes intersect, they intersect at a line. So we would say L1 and L2 intersect at point O, plane P and plane Q intersect at line M. So 2 lines intersect at one point and 2 planes intersect at one line. We would never have an intersection of points because remember, points just kind of exist on their own. They're never going to intersect. They'll always just be separate points. So there's no special term or drawing for intersecting points. So the last part of our notes is just an apply section. And so what I'd like you to do is pause the video and see if you're able to answer these questions. I will zoom out so you can see all of them. And then when you're ready, you can press play and listen to the explanation. So hopefully you were able to give these a try. we have two lines here, line MN and PQ, that are intersecting at point R. Line MN lies in plane A, so you can see that that's plane A, but line PQ does not. Point B lies in plane A, but it is non-collinear with either line. So we have to name two sets of three non-collinear points. So some of your answer choices here, you had a couple options here. We could have said that points M, R, and N would be collinear points because they are all on that line. Another answer could have been points P, R, and Q because they are also on one line together. So either choice would be good there. The next one said three non-collinear points. So we could have said points P, M, and R. That's because if I would try to draw a line through P, M, and R, my line would be bent and then it's not a line anymore. So those would be non-collinear. You also could have said PMQ or PMB or PMN. There's lots of choices here. Name two coplanar lines. So two coplanar lines that we could have here could be line MR, which would be this line. And then another line that exists on that plane, we can't say PQ because if you notice, it goes underneath plane A, and that is just that line intersecting that plane. So another line that's actually there and just wasn't drawn is line BM. So we could say line MR and line BM. Name the intersections of plane A and line PQ. So plane A is right here, and it's intersecting with the line PQ. So the point that it intersects at is right here at point R. And that is the only place that those two things are meeting. So our plane and our line are only touching at that one point. The intersection of line PM and MN. So PM, or the line there, is right here, and MN is right here. So those two lines are intersecting at point M. To give another name for plane A, we can call it a combination of three non-collinear points. So three non-collinear points that are on that plane could be N, B, and M. So I could say BMN. You could also have named it plane BRN or plane BMR. You have lots of combinations there. So in the last example, it says name three planes other than plane A. That could have been plane MRP, and it would be MRP because you can see that these three are points that are not already on the same plane and they are non-collinear. So that could be a plane. We could also have plane MRQ. M, R, and Q are three non-collinear points that are not on the same plane right now. And we could also say plane BMQ because those 3 points are non-collinear and not all of them are currently on plane A. So you had some points there where they did exist on plane A already, but then taking another point that was not on plane A created a new point for us. So you just need 3 non-collinear points to create a new plane. Thanks for watching.